Good morning, everyone. Today, the DLD here, we're going to be talking about lesson 10.6, which is about secants, tangents, and angle measures. Okay, so our objectives will be find measures of angles formed by lines intersecting on or inside a circle. And the second objective there will be finding measures of angles formed by lines intersecting outside the circle. So the first one, lines intersecting on or inside. Second objective, on the outside of the circle. So a definition, a secant is a line that intersects a circle in exactly 2 points. So here in circle C, we can observe 2 secants. Okay, line J is a secant. Line J intersects circle C at 2 points here. So here and here. So line J is a secant, as well as line K that intersects there and there. Okay? So both lines are secants. So intersections inside a circle. Theorem 10.12. If 2 secants or chords intersect in the interior of a circle, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So let's take a look here inside of this example over here. So the measure of angle 1, so we're looking at angle 1 currently. Measure of angle 1 is equal to 1/2 the measure of arc AB. Okay, AB is this arc here. That's the arc intersected by angle 1. And then the arc, or the angle, I suppose, that would be vertical to angle 1 would be referencing this angle. So the arc that its vertical angle intersects is arc DC. So the measure, it's 1/2 the measure of arc AB. Okay, plus measure of arc DC, or CD, as the formula says, either way. Okay. So we can, of course, plug values in there. That's what we'll be working on in our examples, of course. So AB and DC would have values, which would be able to calculate angle 1. Okay. Also, we do need to recall angle 1 and its vertical angle. Vertical angles are congruent, so that's also worth noting. So we remember that. Same thing can happen here with angle 2. The measure of angle 2 is equal to 1/2. Well, what arcs does it intersect? BC and AB. DA. So it applies here in both cases. All right, so let's continue. Example, use intersecting chords or secants. So in part A here, we want to find x. So again, the measure of angle x, we can use our formula. The measure of angle x is equal to 1/2 the sum of the intersecting arcs. The vertical angle, so TU and RS here are the arcs we're looking at. So 130 plus 84. So the measure of angle x is equal to 1/2 of, calculator here, 214. So that is 107 degrees with the x. Right. Here, with example B, we're finding, again, the measure of x. So, we can't find x right off the bat. We can't, it's not the same type of problem that we just did, because we don't have, the arcs we would need to have measures of would be AC and BD. We'd have to have those arcs to be able to find x. It would be 1/2 the sum of those 2 arcs. We don't have those arcs. What I do see here, though, is that angle x and this angle I'm going to highlight here this angle, those would be supplementary. So if we could find our green angle, let's call that angle 2 for a second. So the measure of angle 2 and x should be supplementary. They should add to 180. So if we can find the measure of angle 2, which we can, that's 1/2 the sum of 75 and 143, those two arcs. So let's find out what angle 2 is. I'm just going to plug that all into my calculator at once here. So 1/2 the sum of 75 plus 143 would be 109. So angle 2 there is 109 degrees. So let's just 9 degrees. So again, we said beginning of this problem, measure of angle x plus 109. Those two angles would be supplementary. They would add to 180. So we subtract 109. And of course, we get the measure of angle x is 71 degrees. So that problem was slightly different, but we still had to use theorem 10.12. So at this point, if you guys pause, go ahead and work through problem C. You'll be able to come back and you'll check out how that one works out. So go ahead and pause it, try problem C. All right, so if you've worked on problem C and you're coming back to see how this works out here, we're going to have to kind of go the other direction. We're looking for the measure of an arc, the measure of arc GH. So, well, how does GH relate to what we've been given? Well, we're given the measure of angle GLH. We're given that measure. Well, how does X relate to that? Well, GLH would be 1/2 of measure of arc GH, which is what X is, X degree, plus the measure of arc KJ. So here, substitute, so 110 for angle GLH is equal to 1/2 measure of arc GH, that's X, what we're looking for. KJ is 97. So if we can solve this for X, we'd be in good shape. So to do that, multiply both sides by 2. We've got 220 is equal to X plus 97. So we subtract 97 from both sides. We get that X is 123 degrees. Okay. So let's continue. Theorem 10.13. If a secant and tangent intersect at the point of tangency, okay, so remembering back to Friday's lesson, a tangent, again, is a line that intersects a circle at one point. The point of tangency is where it intersects the circle. So if a secant and tangent intersect at the point of tangency, which is what's going on here, the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so the measure of the angles formed is 1/2 the measure of the intercepted arc. So here this tells us the measure of angle 1 is 1/2. Well, what is the intercepted arc of angle 1? The intercepted arc would be AB. So measure of angle 1 is 1/2 a measure of arc AB, and the measure of angle 2 is 1/2 the measure of arc ACB. Okay. So here in example 2, we'll be using theorem 10.13. Find each measure. So here we're looking for measure of angle QPR. That is QPR. So we're looking for that angle. The measure of angle QR is equal to 1/2 the measure of the intercepted arc. The intercepted arc here for QPR is arc PR. Okay, the measure of arc. So we substituted our value for arc PR. 1/2 of 148. Okay, so the measure of angle QPR would be 74 degrees. Arc
the interruption. All those involved in mentor training for the 2018-2019